This is Accelerated Geometry, Section 9.6, Arc Length. So the measure of an arc is its degree measure. For example, the measure of the arc formed by the hands of a clock at 1 o'clock is 360 degrees in the whole circle, but broken up into 12 sections. So when I take 360 divided by 12, one of those sections between the numbers is 30 degrees. So it would be 30 degrees as the measure of that arc at 1 o'clock. Okay, the question says, what fraction of its circle is each arc? Arc AB is what fraction of circle T? It is 90 degrees out of a total of 360, or 1/4. This goes through the center, so it's a diameter. So CED is 180 degrees out of 360 in the whole circle, or 1/2. EF is 120 degrees out of 360, or 1/3. What is the arc measure of each arc above? So 1/4 of 360 degrees is 1/4 times 360 degrees, so this would be 90 degrees. 1/2 of 360 degrees is 1/2 of 360, or times 360, which is 180 degrees. And 1/3 times 360 gives me 120 degrees. The length of an arc, or arc length, so this is not arc measure anymore. Measure is with degrees. The length of an arc, or arc length, is some fraction of the circumference of its circle. It is measured not in degrees, but in inches, feet, meters, yards, etc. If the circles below have a diameter of 12 inches, what would each arc length be? Okay, so for the first one, this is 93/60ths of the circumference, the entire circumference now, because we're talking about length. So the circumference would be pi times the diameter, so 12 pi. So this is 1/4 of 12 pi, or 3 pi inches. CED is 180 degrees out of 360, so therefore it's 1/2 of the circumference, which is still 12 pi. So 1/2 of 12 pi is 6 pi. And 120 degrees in this arc, so that is 123/60ths of the diameter times pi, which is the circumference. So I have 1/3 times the circumference of 12 pi, which is 4 pi. So conjecture number 87 for section 9.6 says, the length of an arc equals the number of degrees in the arc over 360, so that gives me at the fraction of, or times, the circumference. So if I look at this picture here, the arc length of BC is 90/360ths times 2 pi r, which is 2 pi times the radius of 12. So this reduces to 1/12. When I said 1/4, I should say. 2 times 12 is 24, so 1/4 of 24 would be 6, so it would be 6 pi inches. Find the arc length of these arcs. So I want the arc length of AB. So it would be degrees over 360 times 2 pi r. So the degrees in that arc would be 90 over 360 times 2 pi and the radius of 12. So when I work that out, it's 1/4 of 24 pi, or 6 pi inches. Arc length CED is degrees over 360 times 2 pi r, 180 degrees over 360 times 2 pi 4, 1/2 of 8 pi, or 4 pi inches. GH is 140 degrees. So it'd be 140 over 360 times 2 pi with a radius of 36. So this reduces to 7/18 of 72 pi, which turns out to be 28 pi inches. If the radius of this circle is 24 centimeters and the measure of angle BTA is 60 degrees, what is the length of the arc AB? As soon as I see the length of an arc length, I put down the formula. Degrees over 360 times 2 pi r. Now they told me this is 60, but I know that the arc is twice that because an inscribed angle is half of its intercepted arc. So this arc would be 120 over 360 then times 2 pi with a radius of 24. So that's 1/3, and 2 times 24 is 48. And so when I multiply that, I get 16 pi. Okay, here's the final one. If the length of ROT, so this one goes here, ROT, if that length is 116 pi, what is the radius of the circle? Okay, as soon as they're talking about arc length of this arc, I'm going to write down the formula. Arc length is degrees over 360 times 2 pi r. Now, how many degrees are in that? I come over here and I say ROT is 360 minus this 120 here. That would give me the whole red section, which would be 240. So now I put in 240 over 360. They're telling me the arc length, so I'm going to put this over here as 116 pi. What they don't tell me is anything about the radius. They want me to find that. So I leave 2 pi r. Now I do a little bit of arithmetic and algebra. 240 over 360 reduces down to 2/3. I multiply 2/3 times 2 over 1, and I get 4/3. They both have a pi, so I divide both sides by pi to get rid of pi. And now to get rid of that 4/3, I multiply both sides by 3/4. So here the 3's cancel, the 4's cancel, I'll be left with an r. And here 3/4 times 116 gives me 87. So the radius is 87 meters. So that is the lesson on arc length, section 9.6.